In this video, I'm going to show you how to solve multi-step equations using algebra tiles. Let's first make sure you have an understanding of what the algebra tiles represent. The green rectangle represents a positive 1x, and the red rectangle represents a negative 1x. These are your variable terms. These two together form a zero pair, meaning they would cancel each other out. Your yellow square represents positive 1. Your red square represents negative 1. These two are constant terms, and together they also form a zero pair. Please note that positive terms will change in color, but your negative representations will always be in red. Let's take a look at the equation that we're going to solve together today. The equation is 4x plus 3 equals 2x plus 7. Now notice I've divided my equation into two equal parts. Write down the equal sign. I'm going to refer to these as the left side of my equation and the right side of my equation. Let's model this equation using algebra tiles. 4x can be represented with 4 green 1x tiles. Positive 3 can be represented with 3 yellow square tiles. On my right-hand side, 2x can be represented with 2 green rectangular tiles, and positive 7 can be represented with 7 yellow square tiles. Therefore, I have 4x plus 3 equals 2x plus 7. Okay. Our second step is to form zero pairs with our variable term on the right-hand side. So on the right-hand side, I have a positive 2x, there's 2 green tiles. So I need to add 2 red rectangular tiles to form this zero pair, therefore canceling out this variable term. Now, as with solving any equation, what I do to one side, I must do to the other. So since I added 2 red rectangular tiles to the right side of my equation, I must add 2 red rectangular tiles to the left side of my equation. That cancels out these 2 green tiles because it forms a zero pair. I am left with these 2 green tiles right up here. So what my equation now looks like is 2x, represented with our 2 green rectangular x tiles, and I did not change my constant terms at all. It's still a plus 3 with 3 yellow squares equals 7 with 7 yellow squares. My new equation is 2x plus 3 equals 7. Now that we have our variable terms on one side or isolated on the left side of our equation, I need to work at moving these constant terms or these constant tiles away from my green variable tiles. I must again form zero pairs. So I have 3 yellow square tiles on the left-hand side. I must add 3 red square tiles also to the left-hand side to cancel these out, forming zero pairs. Because I added 3 red squares to the left-hand side of my equation, I must do the same to the right-hand side of my equation, canceling out these 3 yellow squares, forming zero pairs. What I am left with are my 2 green tiles on the left, and 4 yellow tiles on the right. This is what my equation now reads. 2x equals 4. My 2x tiles, my 4 yellow constant tiles. Now, in order to complete the last step, I have to equally divide these variable term tiles, these rectangular tiles, with the tiles on the right-hand side, which happens to be 4 yellow. So I have 1x equals 2, 1x equals 2, therefore giving us a solution of x equals 2.